Welcome to the podcast on solving word problems. We'll be using a process similar to that was on your word problems handout that you did in class. So you can see the format for a word problem that I've started down here below. Clearly defining x, writing your other quantities in terms of x, and then finding something that you can write in two ways. So let's begin. Tom, Maria, and John donated a total of $225 to charity. Maria gave $25 less than twice what John gave. John gave 3 times what Tom gave. How much did each of them donate? Well, the first thing we have to do is decide what x is. The way you do that is you go to what the question asks and you try to let x be whatever the question wants you to find. But the question wants us to find 3 different things. It says how much did each of them donate? We know that they didn't all donate the same amount, so we can't say let x be the amount each of them donated, because that would be trying to let x be more than one thing at a time. X can only be one thing. So what we're going to have to do is either let x be what Tom donated, or what Maria donated, or what John donated. Now it says in the second line, Maria gave 25 less than twice what John gave. So if I let x be what John gave, then Maria's gift would be 2x minus 25. Remember that less than is a reversing phrase, so the 25 would have to go last. But if John gave x, John gave 3 times what Tom gave. So how would you say what Tom gave? Not 3x. If Tom gave x, then it's John that gave 3x, 3 times what Tom gave. So I think the best way to start this is to let x be what Tom gave, so that's what I'm going to do. Let x be Tom's donation, or what Tom gave. Now I've kind of given you a hint here that it was going to be Tom, because didn't mean to have that there, because in the second line I've given you that then blank is what John gave. So you knew not to use John in the first line. So okay, if x is what Tom gave, let's go to John. John gave 3 times what Tom gave, so that would be 3x. And if I've already talked about what Tom gave, that would be x. And I've already talked about what John gave, that would be, Tom gave x, John gave 3x, then the only person left is Maria, so the last line would be what Maria gave. Now let's go back over that. That's a little more complicated. Maria gave 25 less than. In a reversing phrase, the first number comes last, so this is going to end minus 25. And it's 25 less than twice what John gave. You might be tempted here to put 2x, but remember x is what Tom gave, not what John gave. John gave 3x, so twice what John gave would be twice 3x, not twice x. So now if you want to refer to what Tom gave, say x. If you want to refer to what John gave, say 3x. And if you want to talk about what Maria gave, say 6x minus 25. Okay, the next one says figure out something you can write 2 ways. Well, look up here. This 225 is the total given by all 3, and we haven't used it yet. So if I'm looking for one way to write the total that both gave, or that all 3 gave, the easiest way to write it is just going to be to write 225, because it says in the problem, all together they gave 225. But what would be a second way to do it? Well, a second way to do it would be to say the total that they gave was Tom's donation plus John's donation plus Mary's donation. And if you add up those 3 donations, that's what they all gave. So Tom's donation was x, John's donation was 3x, and Mary's donation was twice 3x, or twice John's donation minus $25. So if both of these are the total donated, there's only one total donated. So both of these numbers have to be the same because they're both the total donation. So my setup equation is the total amount donated is equal to the total amount donated, and that's kind of hard to argue with. Certainly the total donated has to equal the total donated. So let's go ahead and finish this off. I want to get to simplify this part, but let's just simplify all these x parts because it's really simple to do. 1x plus 3x is 4x plus 6x is 10x minus 25 equals 225. Add 25 to both sides and you get 250 equals 10x. Divide both sides by 10. The 10s cancel. The 10s also cancel over here. And you get x is equal to 25, and that's what Tom gave, because we let x be what Tom gave. So what did John give? Well, 3 times x is what John gave, so 3 times 25 would be 75. That's John's gift. And then Mary's gift was 2 times 3x minus 25. So 3x was 75, so twice that's 150. Minus 25 is 125 that Mary gave. Let's see if that worked. 5 and 5 and 5 is 15. 10 and 2 is 12. Carry the 1. In total, they gave 225. That's what the problem says. So that appears to have worked. So let's go on now to problem 2. It says Jill's cell phone plan costs $45 a month. She gets 2,000 free minutes per month, but she has to pay 4 cents a minute for each additional minute. If her May bill came to $58, excluding any additional fees or taxes, how many minutes were put on her phone in the May billing period? So since it says excluding any fees or taxes, we can figure this 58 is just the monthly fee plus extra minutes. And the question asks, how many minutes were put on the phone in the May period? So let's just use that. That's just one thing, so we can let x be that thing. Let x be the number of minutes used on May bill. So that's a total number of minutes used. So how many of those minutes did we actually pay for? Well, we didn't pay for the first 2,000 minutes. The first 2,000 minutes are free. So if x is the total number of minutes, then x minus 2,000 would be the number of minutes at 4 cents. For example, if she talked a total of 3,000 minutes, then 3,000 minus 2,000, or 1,000, would be the number of minutes at 4 cents per minute. So we've got to write an equation here, and I'm thinking the equation could be on the total bill 58, which we haven't used yet. So I could say, write the total bill two ways. And the first way, the easy way, would be $58. So how else would you get the total bill? Well, it would be the monthly fee plus the minutes fee. That's the extra minutes fee. So what would that be? Well, the monthly fee is $45. Plus, what did we pay for the extra minutes? Well, we have to go back to where we defined how many extra minutes were bought. And we said the number of extra minutes was x minus 2,000. And how much do those minutes cost us? You know, like if that's 1,000 minutes, how do we figure out the amount? Well, it's 4 cents a minute, so we'll just multiply by 4 cents. Now, notice I said 4 cents, but I didn't write 4. I wrote 0.04 because I'm doing the problem in dollars. 45 was dollars and 4 cents is $0.04. I couldn't have an expression in dollars here and an expression in cents here because they're not like terms. They wouldn't add up. So now I'm ready to go ahead. 58 is the total bill. 45 plus 0.04 times x minus 2,000 is the total bill. So both of those have to be the same. So I say 58 is equal to 45 plus 0.04 times x minus 2,000. I'm going to let you go ahead and stop the recording now so that you can work that out, and then after you come back you can see if you worked it out the same way that I did. Okay, we're back again. Here's how I worked it. I first distributed my 0.04 to get 0.04x minus 80. Then I wanted to get my x terms on one side, non-x to the other, so I moved the 45 by subtracting 45, and I moved the 80 by adding 80. Then I did the same thing on the left. So on the right I ended up with 0.04x, on the left I ended up with 93. I divided both sides by 0.04, and I got 2,325 minutes. Now let's see if that's right. How many minutes did she pay for? She used a total of 2,325, but 2,000 were free. That means she used 325 that she paid for. If you multiply that by 0.04, you get 20. 8 and 2 is 10. 12 and 1 is 13, $13. And if you add that to the 45 base fee, you get the total bill of 58. So we know that that's the correct answer. Okay, let's go to one last problem. And this problem is a bit more complicated than the first two because a lot of stuff is going on. It says Jerry bought a wool business suit at a 20% off sale. He used a coupon worth an additional $20 off any purchase over $100. He paid 8% sales tax, which brought his total bill to $142.56. What was the original non-sale price of the suit? So I would start off by saying let X be the original price of the suit. Now what I'm going to do here is I'm going to stop the recording so that you can attempt it yourself, but here's what you need to consider. You've got two discounts. One is a % discount and one is just a dollar discount. And then you've got one thing that's going to make it go up instead of being a discount, and that's the 8% sales tax. So the 20% discount will lower the cost. The $20 off coupon will lower the cost, but the sales tax will raise the cost, and then this is your final amount. So give that a try, see if you can set it up and work it, then click back on and see if you did what I did. So we're back again. Let me show you what I did. If X was the original price of the suit and you get 20% off, remember if you save 20% you pay 80%. So 0.80X is the 20% discounted price. Now in addition to the 20% off, he also had a $20 coupon. This time you don't do it as a 0.80 because you're not taking off a percent, you're taking off a number of dollars. So the cost after the coupon would be the 0.80x, which is the discounted price of the suit, less the $20. And then we're going to go up in price. Now what we're going to do is take this final price, we're going to go to the cash register, and at the cash register they're going to add 8%. When you increase a number by 8%, you multiply it by 1.08. But we're not going to do the X times 1.08. That was the original price of the suit, and that's not what we're paying. This is what we're paying right here. So we want 1.08 times that number, and that'll be the price after the sales tax. So that gives us this set up. So go ahead now and see if you can solve that, and then click back on after you've got a solution and see if it's the same as mine. So here's my solution. If you want to get that copied down, just freeze the recording because in a couple of seconds I'm going to end the podcast. So this completes the podcast on solving word problems.